I wanted to walk through 6.07. Some people had some questions. So I have the document that you're supposed to be filling in over on the right, and then you have your collision cart simulation over on the left. So, starting with the first instruction, it says to select the double arrow button in the top left to resize. So we can make it lots larger. Okay, so we can see what's going on there. I'm going to minimize it though so I can see the instructions again, but that's how you can make it larger. Alright, you can change the mass here on the bottom, and you can change the velocity using these. You can make the velocity positive, or you can make the velocity negative. So if we scroll down, the first thing that we need to do is set the velocity of the blue car to 0. So we don't want the blue car moving at all at first, and that's exactly what you see in the image there. And then we're going to set the red car to whatever you prefer. So you're going to pick a velocity for the red car, whatever you want it to be, right? If you'll notice in the picture, they give us right here, they have it moving to the right. So I would suggest that you choose a positive velocity to match what's going on here. Whatever velocity you pick, you're going to record it right there. Then you're going to determine the mass of each car. It doesn't say, what the mass should be, so you can just choose and record what masses you chose for each one. Alright, so far so good. So now we scroll down, and we're going to run the simulation. So once you have your velocity set, make sure you have it on elastic collision, and then you're going to run the simulation. Alright, once your simulation is run, you then want to record what your velocities are after. So after they run into each other, pause it and see what the velocities are. Let me get out of this. So over here, after you run, you're recording your final velocity for the red and your final velocity for the blue. Alright, so everyone's been doing that okay, but then it's down here where we get confused. So right here, you're just filling in your red mass before the collision. That's just however much you chose for your red cart. Then your red velocity before the collision. That's how fast you set the red one to go before. Your blue mass, just in general, what mass did you choose for your blue? And then your blue velocity before the collision should be 0. You should have set it to 0. If you didn't, you'll need to rerun it so that it's set to 0 at the beginning. After the collision, your red mass should be the same. Okay, the collision doesn't change the mass, but the red will have a different velocity. And the blue mass will be the same, and the blue will have a different velocity. Now for the math, we're calculating momentum. So we're going to calculate our mass times our velocity for each one. And we'll record it right here. Mass times velocity, mass times velocity. It should be 0 for the blue momentum before because it wasn't traveling, and then the mass times the velocity for the blue after. Alright, once you get those values, you can then calculate your system totals and your momentum change. Now for system total, you're just going to add red plus blue, so you're just adding this number plus this number. That'll give you your total, and then this number plus this number for your total after. For your change in momentum, you're subtracting the before and after. So red car before minus red car after gives us the change. That's what that triangle means. Then blue car before minus blue car after gives me the change for the blue car. These values can and likely will be negative for one of them. Alright, so that's how you fill in the table. Now let's look at part 3. Very similar. The difference, though, is that both cars are going to be moving before they're going to have an initial velocity. So you're going to choose a velocity for the red car and then make the blue car move at some speed that is less than the red car. So you'll have your red car velocity and your blue car. You'll set your masses. You want the blue car's mass to be less than the red car, but you can choose anything. They can't be the same, and you want blue to be less than red. Right? Then you're going to kind of scoot the blue car over so that they collide more in the middle instead of having the blue all the way over there. And then you're going to run the simulation. After you run it, record your final velocities. Okay, and then we're going to do those same calculations again. So we've got the red car's mass and the blue car's mass are going to go into these spots. Red car on the top line, blue car on the bottom. The red car's velocity before and after, blues before and after. You multiply to get your momentum. You're going to subtract those two to find your change. Subtract those two to find your change for blue. You'll add the blue and the red to find your total before. Add the blue and the red to find your total after. What you should see, hopefully, is that your system total before and after is the same. That's what the law of conservation of momentum says, that momentum before anything occurs should be the same as momentum after, as long as there's no energy coming in from outside the system, which here we just have two cars colliding. So there shouldn't be any energy entering from outside the system. All right, let me know if you have additional questions after you watch the video.